Hi, folks. Welcome to the August version of the Pyroscope community call. If you've been here before, you know the drill. Go into the chat and leave comments there. If you're new to this, it doesn't let you do anything with the chat. You may need to go actually and create a channel in order to be able to chat. So please go and do that. Um, so yeah, basically today we're going to be talking about the source code integration UI improvements and also the new eBPF profiler and Alloy. And then also if you have questions after we do everything today, you can go over to slack.grafana.com and you can join us over there and ask questions that you may have there. And so, yeah, I'm going to pass it over to Christian, and also I'm going to comment in the share a link for the previous version that we did that was for the source code integration that maybe went a little deeper into some other parts of it.
Yeah, hey everyone. Yeah, like I basically have a couple of updates. I think the last couple of calls we announced a lot of things, and now I guess you can actually start using them. Roughly the agenda for today. I'd like to start with the source code integration. I guess why is it useful? How does it work to kind of fetch your source code? And then yeah, actually I will gonna go straight into the demo. And we might see a couple of limitations so during the demo, and that's maybe why I want to look at what's next for the source code integration. Where are the current limits? We also will look into the new OTel eBPF profiler backend, which has been merged now, and also go slightly back to the demo and see this in action. Cool. So yeah, any questions? Basically, feel free to comment or actually wait till the Q&A section. I'm happy with either. So why would you want this source code integration? So a profile obviously allows you to analyze the resource consumption of your running software, and especially if it's continuous profiling, you're running software in production, and you tend to kind of look at aggregations like a flame graph where everything is broken down by the call stack, and you can see basically it broken down by function name there. But the way we kind of collect profiles, actually we have even more information than just the function name. We actually know which part of the instruction, I guess, the program is running at. And to get to the function name, we actually need to figure out this particular address, what kind of it means. Uh, when it comes to the call stack of the program, and part of that we can basically also recover the file name and the source code line. So typically, mostly speaking about compiled languages now, but you have source code, you have a compiler, in the end you have a binary, and then basically in that binary the kind of this binary code, there's no longer source code, so you won't be able to make much sense of it without any additional tools. And so basically, part of that, we kind of translate the addresses again back to where they kind of once came from. And this basically will then yield us the file name, where the kind of compiled file was that translated in that binary code, and the line number. So while kind of the pprof model that we use kind of allows to do that kind of for pretty much any languages. Right now, I think the ecosystem is mostly targeted towards Go, and that's where I guess we have all the data available. So most of the things I'm going to show you today, are very Go specific, but we have a couple of ideas how we can bring this to other languages and what is next there. So in order to then come kind of so you have the profile, you have the information about the file path. You also need to know kind of what version of the source code it is and where you would find the source code, because obviously, like in a binary, it doesn't contain the source code anymore, so it needs to kind of come from somewhere. So previously, we kind of introduced, that was an accident, this kind of notation with the labels here. So we basically want you to map a Git reference and its Git URL to kind of show you where the source code lives. While this is kind of nice if you have everything automated, and you might kind of have the problem that like there's another service that you didn't do those labels, and that's basically where we kind of improved the way the UI can select the source code. So those labels can now be overwritten in the UI, and that's kind of quite useful, especially when it comes to incidents, or like when you kind of slightly think you're using the wrong version, you can basically adapt that version and like help you to kind of to show the right source code. So generally, the source code integration is available in Grafana Cloud and in OSS. So the like kind of those two are links. So if you open the slide links, you can kind of go directly there. But it was also recently shared. The kind of direct docs on this. I think Tiffany, you shared them.
Yeah.
For Grafana Cloud, you have less to do. I guess in that case, we already set up the kind of GitHub credentials, GitHub account, but the OSS docs will kind of guide you through those steps, and kind of it works in both, and the kind of functionality is the same there.
And I was looking at the docs and it was mentioning that it was only source code mapping is only available to people who have access to the source code in GitHub. Does that mean it has to be inside of one of your repositories, or just the code needs to be public?
Like it needs to be, you need to have access in GitHub. So you're kind of using your rights as Christian Simon, if it's in my case. And so, for example, I also have access to the closed source Grafana source code. So if I open that, I can see all that source code as well. So basically, like it follows like your GitHub user.
Okay, so like say basically like, but does it need to be something that where I have like edit rights on the code, or just where I can actually
No, so
just see
like
the code?
most
Like,
code, I guess, of your dependencies is most likely gonna public, and you can use that. And like obviously for private code, you need to have access, otherwise there's no way for us to recover that. And yeah, we're basically like logging you in using like OAuth style, and you will be logged in as the Tiffany GitHub user, and using kind of your permissions and rate limits. So if you are able to see more source code, then you will see it. I won't. So I don't know. Internally, we kind of like have that off, or we basically need to authenticate another time to access Grafana source code. This is also necessary to do that before I can see it in the source code integration. So there's no loophole, I guess.
yeah, Brian saying simplified, you can't view source code that is private and you don't have access. Makes sense.
Yeah.
And then, so like say whether it's on Grafana Cloud, you have to go and configure it. Are there any plans to make it so it's just a thing that's already there that you don't have to actually do any sort of like specific stuff to set up?
Yeah, so like basically like in Grafana Cloud, you don't have to do anything specific.
Okay.
In OSS, that's kind of where you have to do a bit more kind of GitHub account creation. So like I guess the thing that we made slightly simpler is we no longer require those labels to be there. So the labels is something that need to be there when you collect the profile, and you can not easily add them later. And obviously with being able to override labels in the UI, or that kind of settings in the UI, you kind of like don't have to think about it before, so you can collect the profile and then later start using the source code integration. So I do think this kind of made it a bit simpler. So in general, like I think it will become a lot clearer as well when we go to the demo. So I guess where we are right now, we basically have the profile, we have the file name, and we have the file path. We know the source code repo, and yeah, it's kind of reference. So as the next step, we kind of need to clean up the source file. Like often when you compile something, you might have artifacts. Like for example, in my laptop, I have all my source code in home Christian Git, and like that might be the kind of full file path. And so obviously, like this kind of structure is different for if Tiffany checks out the code and builds it. So we basically need to kind of do some cleaning up to find the right source file. And also in the Go case, there are a couple of ways of how you maybe handle dependencies, and we currently support the basically Go mod build. And we support basically Go mod render when it's part of the source code repository. There's also like another special thing where we have to handle the standard library slightly different, and so this is kind of very specific to the language, and there are actually ways that we kind of don't support in Go right now, so that you might, for example, use a different build tool like Bazel to build your Go code, and in that case, the Git repository won't contain the source code, and there's not a kind of direct link. I will talk a bit later in what's next about how we can actually fix that and allow more custom ways of building source code, which then also will help to adopt more languages. In general, like one of the core principles for us was we don't want the user to upload us the whole of the source code. So we actually want to be not in a position where we kind of have to store source code and all of the source code for a long time. So we really only want to process maybe just one file because the user has requested it, and then it's also a lot easier for our customers to audit like what we access, because in the case when I go to one file, it will be very clear that I guess I requested that, and then basically like our backend then maybe requests the Go mod file and another source file, but it will be very clear, like at no point we will have the whole source code, or we could leak it, and we will also not store it persistently. It will basically be processed and will be in memory only. So let's maybe actually look at this a bit more in action. So what I've done here, and I need to share the right tab. So this is basically like a Grafana cloud that I'm using, and I kind of deployed it to my toy cluster, let's say. So I'm running a few applications for, yeah, managing a few things, and like you can see, like kind of the services that have been like discovered here. Like I've not cared much about any of those services, so I've not set up those labels. And so previously, like you kind of would have gotten. So probably I just start with the Alloy that actually component that collects the observability for us. So you can kind of see how the flame graph is here. I can maybe get an idea what this Alloy is doing by figuring out. So we can see we run some file match components, and then we actually process some low key stages. So most likely this is the Alloy that processes my logs and its usage in a cluster. So if I want to go a bit further, then I obviously want to see the function details. And now, as I haven't set up those labels, I'm not able. But actually, with this new UI, you can see here, I can actually override this. And so I guess in my case, I want the source code to come from Alloy. This is publicly available, so everyone who runs Alloy can use that. And then I also know need to know the version I want. So I can basically like just set something like head, which is the main branch. But if I actually know which version it is, I can also type this here. And so now it offers me to connect to GitHub, which I'm now doing. Because I've done that before, it doesn't require any additional steps. And now what we can see is we kind of see the source code loading and yeah, overlaying the information in the profile with where that's basically like coming from in the source code line. I can also go directly to the file and basically like as you can see, this source code name, this file name here contains like slightly more information, and that needs to be cleaned up. That was kind of the thing I was talking about. And so if I think now like, oh, I have selected actually the wrong commit, I can also change that and change it to a newer version of Alloy. And yeah, and that's basically like allows you in incidents kind of to react a lot quicker, and basically like don't require you to set up everything. there might be even components that like you don't know yet you have a problem about. So in this case, we looked at Alloy. I'm fairly familiar with Alloy. I have a couple of PRs there, and we obviously maintain the profiling code there. But it might be something like I don't know, like DNS. So like usually most problems are somewhat related to DNS. So there might be a use case where I want to look more into the kind of cluster DNS, which is this core DNS deployment here. And while I can kind of already make a lot of sense what this is doing by just the function names, I obviously like I'm able to go a lot deeper if I'm now opening the source code here. And I guess in the same way, so we can say like pretty large contributors to the resource usage are the DNS serving, the metrics pipeline, and this is kind of some health check by the looks of it. But if I actually want to figure out a bit more what this is doing, I obviously want to look at the source code. And for this, it is an open source project, so I maybe just figure out. Oh no, that's one thing I wanted to do. Just figure out where the repo is, and I think you should be able to see it. So core DNS GitHub. So this is basically like where the source code lives, and now I'm going back, and we can see like how the code is loading now. So while I'm not exactly sure which version it is, I definitely can see this kind of being like accurate. So you can see how we are in the check function here. That is also the check function that we clicked, and so for example, the check function calls send, and then here send, if I want to know what kind of the send function does and where it spends the time, which basically like I can see that it spends the time all exclusively in exchange, which also matches, I guess, with the exchange here. So those all other contributions are significantly smaller, and so you can basically go down the whole way until I guess you figure out where the code where the CPU usage is spent.
So by default, it wasn't you had to go and like put in the repo that you were specifically going
So
from.
like
Is it
you
just
will always need a repo. That's the kind of required.
so does it is it basically like so putting the repo in there? It's not because like you're running your application, right? And obviously it makes the calls and it hits whether it's core DNS or Alloy or whatever the heck it is that's happening. What is it that makes it so that you have to specifically put in the repo versus it knowing because it's called different libraries?
Yeah, so like I guess in theory we can probably infer it. Like I guess we know the application is called core DNS, and that if we maybe use AI to ask where the source code for core DNS lives, the answer might be core DNS. But obviously, like we don't know that for sure, or like that's not a mapping, I guess, that we can safely say. So that's why I basically need to give it where the source code lives. So we don't have that information currently. At collection time, I guess, where is your source code? So I definitely think this is possible to relay that in binary. So I don't think all Go binaries contain the source code or source code hash, but like there's definitely a way to include them into the build artifacts.
Yeah, what if like so like obviously you have you're running your binary, so it may not know all that kind of stuff, but like if there's an option of like, hey, here is the overall code base that this is calling, and then that should be able to see, hey, what libraries are being used if it has access to the original code, because then otherwise you wouldn't have to put in like this is the one for core DNS, and then you have to figure out and like how does it work if like say, hey, right now, yeah, you're running head for your binary. If you were to switch it to some specific Git like version, or Git reference, does that like how does that change things? Because you're still running the code specifically using
so basically
maybe
like
not
if I'm
that
using
one, right?
the wrong checkout, then I will find that maybe a comment is using CPU or some oddities like this. I obviously need to quickly look up what core DNS version I'm actually running. Let me just do this quickly. Core DNS.
Yeah, because I figured like if you were able to give it access to like, hey, this is like if it's something that you have all of the code originally, like maybe it's a binary you made, being like, hey, here's my repo, and that it based on that it can see where everything's coming from, since Go knows when you're building it where these different things originally came from, and then what versions are being used. So that way you don't have to be like, oh, here, let me go to core DNS and put in the repository. Here, let me go to Alloy, put in the repository. If you have
like this is
the whole
definitely
picture.
like, I think maybe also like a problem that we are very early in that process. So like right now, obviously, if you look at some of the kind of code here, so here you could see the starts in core DNS. Like the kind of call stack we look in here. So like likely this is the right source repo. But I think this is kind of a benefit of Go that the package name contains the source repo. So I do think this is something that we need to detect when we collect the profile. We don't do this right now. And theoretically, we could also look at two versions of core DNS. And while we handle that, if you put your labels in, because when you put the label, as described earlier, so the service gitref, you could look at two labels. So you could look at two versions, and you can actually select which one you want to look at, because they might be contributing differently to the flame graph. Right now, that's kind of not possible if we don't detect that early in the process, I guess.
And then like right now, there's a bunch of like gray parts which are on the flame graph, which are things that aren't taking nearly as much time or CPU and memory, and we don't care as much. But is there a way to like look into that stuff more easily? Like, is there any way to zoom in onto things?
So like zooming in, like is basically like the focus block feature, so you can see
Okay,
how
right.
much more appears here. So remember, I kind of went into the health check before. And like we can see how health check
That's how
calls
you jumped
check,
into that.
calls
Okay.
send, and so on. And now I guess we can also see like other parts. So like we were in send earlier, so I guess where we can see the kind of like a call to exchange and to set question, which I can't see right now. So like I also like just found out the version. So in this case, I'm running like the 11.3. So I don't think this will change anything. But now I guess like we basically see the same thing. But if that version wouldn't be right, we might see some really odd behavior. We might not even be in the send function here. And so like yeah, I guess you can kind of see how this health check, I guess, uses then UDP connection, which then eventually becomes a kernel call slightly further down the line. And while I guess we and so like here we can kind of see where this kind of starts to break down. Like in this case, we have a path that we can't resolve. So like that there's a lot of those kind of edge cases where basically like in this case this is the tool the Go tool chain Go mod, and for some reason we don't pass this correctly and are not able to resolve the source code. And like that, while we're working very hard to kind of get all those identified, there can be still a lot of those cases where we basically like don't clean up the paths correctly and you see no match. So I definitely encourage people to report those, and we basically need to add we need to kind of add those into our test suite. but basically, like the takeaway for you should be no longer setting the labels does not prevent you from using the source code integration. So you can basically start using like the profile as soon as it's there. I'm probably going to move on now to the bit about the eBPF integration. Oh, sorry. First, let's think about like what kind of are the gaps right now. So you kind of saw me when I was moving around the source code. It's kind of hard to keep track when you're kind of moving up and down functions. So we want to kind of improve the navigation, that you see which function currently at. It should be highlighted, and you should be able to kind of connect the next steps. We also kind of found a lot of those edge cases and a lot of custom built versions of Go binaries, and so we want to investigate how we can support those better. So currently we're thinking we want to kind of allow people to self-host source code. So when I said earlier that one of our design choices was to avoid owning the whole source code, we kind of don't want to move away from that. But for some kind of languages or for some build tools, it is kind of very important to own the whole of source code. So we kind of hit that when a customer who uses Bazel to build Go came to us that they can't resolve their dependencies there. So Bazel kind of needs the full tree, needs to have the full source code in order to kind of fetch the dependencies and like have them available. And so basically, like our thinking is now that we will host a source code server that is or we will not host the source code server. We will host that at the customer side, and the customer will have to kind of basically like give that access to the source code and then can control source code access through that. So we will still not own the source code. All the calls will still go to the self-hosted source code server. I also linked kind of the proof of concept I've done for this Bazel Go, but I do think this could be a good gateway of like venturing into multiple languages, because for other languages you need kind of slightly other ways of fetching the kind of dependency source code, and I do think it will allow us to kind of iterate quicker on this when we have different source code servers doing this kind of work for us.
And I'm going to throw in a question.
Yeah.
The question is whether it's possible to integrate with Azure DevOps.
Okay, Azure DevOps. I don't know. Is that
Or at
like?
least I assume that's what AZ stands for.
So like I'm not fully sure what what Azure DevOps does. So I imagine it is some CI/CD, or maybe Alexandra, can you maybe provide a bit more on which way to integrate? It could also be like that it's kind of a source code host. I will come back to you when we when you give me a few more pointers. So I guess in general, if whatever the service you kind of use to store your source code, with this ability to self-host your server, you can kind of integrate with those systems. So like basically the answer is, like give me this file as kind of the request the source code server gets, or resolve that commit for me, and as long as you can kind of answer those. Like the POC that I wrote for Bazel works with any Git. So Azure DevOps is basically a Git hosting service, as far as the command says, and the kind of Bazel POC uses Git clone and then the URL. So as long as that is possible, that will work. In the traditional implementation that we used, we didn't fully well, we couldn't really use Git in the sense that we then wouldn't like own too much of the source code, or we felt that is too invasive, and so that's why we kind of went for the GitHub API. I do think the quickest way to support like any use case will be this kind of like API that we allow customers, I guess, to integrate with.
Yeah, so I think the answer kind of got figured out, but basically the source code is a repo on Azure DevOps, but the question and statement was about whether it's just only GitHub or any platform that's Git-like, and right now it's just GitHub, correct?
Yeah, so like the thing that we host on our end, I do think this will stay probably like cloud services for a while. So while it's GitHub right now, like GitLab definitely has the same ways of, or GitLab.com has the same ways of integrating. But if you have more something like I don't know, less common, um, we might ask you maybe to self-host the service. And right now I have a POC, but I do want this to be kind of a supported thing that is part of the main Pyroscope project, the source code server, and this should only rely on Git. And then I guess like everything that source code server has access on Git then will be kind of shown to the users. I hope that makes sense, Alexandre. If you have any more questions, definitely ask them, and I guess we get back to you. Yeah, so like the other kind of thing that like we need to improve is this kind of end-to-end passing of information. I guess we discovered that the Go version used right now is not known, and we kind of either have to guess it or we use the latest, which is not correct in all cases. And so we basically want to detect the Go version. We want to be able to detect the source repo URL, the commit hash, and then basically like pass that through all the way into Pyroscope and then use it in the UI. Right now, there's a couple of things preventing us from doing this, and I hope with the adoption of the OTLP format and the SEMconv around OTLP attributes, it will help us to kind of propagate that information properly and also build it into most, if not all, profilers. Something we also want to kind of make slightly better. If you kind of remember, we are in the kind of source code view here, for example, but like while we offer you a view on GitHub, I think one of the natural steps would be to open it in your IDE. And right now, there's basically no good way, and obviously there's a lot of IDEs, and people have a lot of different preferences. But we basically want to have a better way of kind of getting you to the next step, and maybe even showing you information. So we obviously have the MCP server. I think it was also part of one of the last community calls. Like there might be some way of kind of bringing those two a bit closer together, that it feels a bit more natural. And yeah, that was really it. I definitely think there's a lot of insights to get from looking at the profiles using something like the source code integrations. So seeing directly, I guess, what happens there, like reading the context from comments. And I do think this is very powerful. So we will kind of continue to invest in that. So I guess now slightly like topic change. So we also kind of spoke about this before, but now actually the PI is merged, and the next release of Alloy version 1.11 will contain the OTel eBPF profiler. So we kind of replaced our own profiler from Pyroscope.eBPF with a new one, and there's no option to get the old one back. We basically like want to go all in on the OTL, the OTel eBPF profiler, and that has a couple of reasons, but basically like that profiler like has a lot wider language support. It like provides, obviously OTel provides us with a good way of working together with other companies, and multiple vendors can bring their expertise to it. So I definitely imagine it to move a lot quicker than our eBPF profiler. And so I guess you can already see that, like currently, like the kind of language support in the version 1.10 of Alloy was basically only Python as a high level language. Is why we, by adopting the OTel eBPF profiler, can support like the JVM, Node.js, PHP, Perl, and Ruby, and .NET. Remember, all of that is only CPU profile types. So this will this will like only be able to look at the the timing when CPU is used. And there's also a feature for off CPU profiling, which kind of highlights when something stops using the CPU. It will not exactly tell you what it is doing because it's not using the CPU in that time, but most of the time from the context of the stack trace, you will be able to kind of get that answers. There's also like a lot more wider features in the PRs, like so the like one of the things I'm looking forward is the ability to kind of profile actual U probes. So U probes can basically like count how often a certain function has been called, and you then can see where they were calling from. That could be very interesting for like memalloc kind of functions, or wherever you kind of gain access to something that is scarce resource. So that's pretty exciting.
I have two questions for you.
Mhm.
One, in case some people who are watching are newer to all this, could you give like a really quick synopsis as to what Alloy is and how it's beneficial here in general?
Yeah, so like Alloy is basically like our hotel collector distribution from Grafana Labs. So like the idea is that basically like all your observability collection should go through Alloy and then go to the kind of destination, which can be Grafana Cloud, could also be another vendor. And I guess you can kind of modify things on the way. You can select what do you want to collect, and I guess in the case for profiling, like Alloy would be kind of controlling how often should what process be profiled, and then also kind of collecting more metadata around, like I don't know, what part is this running in, what container. Maybe one day, as we mentioned before, we also want to collect the information about which Go version, what is the binary source code Git, and what is the Git ref. Information like this is basically Alloy's job to collect them and ship them off to Grafana Cloud or to Pyroscope or to any kind of product that supports the kind of the protocols.
And then I have a question from Alexandra from earlier that's relevant to this, whether the profiler is also included with Bela or just an Alloy.
So right now, like while Baylor and the eBPF profiler do similar things, right now they don't work together in a sense. So there are slightly different things. So what basically Baylor does, it's doing distributed tracing. For that, it interferes with the way HTTP messages or like other network communication is happening to kind of associate information about the trace with it. And so like it will give you basically distributed tracing gives you a view kind of one request, how it passes through your system. And profiling is more like on a node, you know what a process is using CPU, what this process is using CPU on. And there's obviously the intersection of them too. If one request uses quite a lot of CPU, we would be able to associate that. Right now, that's not possible yet. But with I don't know how much you follow that, but like Baylor has also kind of been donated to Hotel, and there is the plan that this is kind of shared, the information about what trace is running on together with the function that has been called could be information in the profile, and so um, this will basically like help you to understand when a particular request uses quite a lot of CPU and where this request is coming from, like what other services were involved, and I definitely think this gives you a pretty good view of um, like what caused this, what request caused this. Like you can kind of basically like work backwards what what led to that state of I don't know, high CPU usage. Let's say you have a bug, you would figure out from the trace which customer sent it, what is their request ID and browser and so on, and could hopefully like reproduce it a lot quicker. if not quickly spot where the problem lays combined by the two. So I don't really have a great update or timeline for this, but this is definitely something that will be possible to kind of share that context with the eBPF profile, especially because I guess they work on the same level. They do kind of roughly the same work, being able to trace processes, understand what kind of language ecosystem they are, and this could be a great integration point for them too. Right now, there's not the right mechanisms in place in OTel, but I do think we will see this in the next 6 months.
And then, like, so at least with the profiler before this one, there were in the docs it was talking about how you needed to enable frame pointers. Is that something that you still I think that's something you don't need to care as much about with this, or is that something you still have to worry about now?
Yeah, so like I'm not super familiar with the details, but I do think this is no longer necessary in all cases. So the there are a couple of techniques to walk the stack without frame pointers, and I do think the OTel profiler is able to do them.
And that was my understanding, but I wanted to verify. All right, carry on.
Yes, like I basically wanted to quickly jump back to the demo. So what I kind of didn't mention before is like all of those profiles that we have here, they are actually collected using this new eBPF profiler, while the old profiler would not be able to kind of show you the file path and the source code information. The new eBPF profiler is also able to extract that information, and basically that's kind of why we kind of see also kernel level functions here. So we can see kind of this is all, I guess, go up till a point, and then I guess you hit through the syscall, I guess you interface with the Linux kernel, and this is, I guess, visibility you didn't have before when you were only using like kind of the Go pprof profiles, or with eBPF you wouldn't have with the Pyroscope eBPF you wouldn't have this kind of resolution of line numbers. So no, that is a pretty exciting feature, and like I'm running on my hobby machine. I'm running a few things that are not Go. So for example, GitLab is one of them. So you can see a lot of deep stack traces there of Ruby. Or I also have some Java, I think. I think it's this controller here that runs Java. Obviously, I don't really know much about, but this looks pretty much like Java code and Java function names. So this is kind of something that we got by kind of adopting the OTel profiler, and yeah, like we are able to kind of resolve those now. So basically, like I also have a small call for action. So the next release of Alloy will contain a new profiler, and I also provided some instructions here how I can test this today, and especially if you're running a lot of services that have not been supported before, I would like to kind of make use of the new profiler and hopefully like find no bugs at all and just have better profiling data. But in the off chance you find some regressions, we definitely want to know about them. Yeah, like as soon as possible, and address them before we have to release. And this was kind of all the content I'd prepared.
Awesome.
But I'm happy to chat about anything else.
Yeah, so folks, if you have any questions, definitely please ask them, whether it's in here, if you have something at the moment, or if you think about something later. As you can see on the slide, if you go to slack.grafana.com, that is for the community Slack, and you can go to the Periscope channel. There's Tempo, a bunch of other stuff too. I can share again the link if you're interested in watching more about source code integration from before. Let me double check that I'm copying the right link. Okay, so I'm sharing that again for folks who missed it from earlier. And then also, if you want to look at the slides and be able to click onto the links, I'm adding that in the chat again as well. And then we'll be having another community call in about a month as well. So please obviously come and join us again for that one. And since it's going to be the first time of going and running the community call on right back to back, where I'm dealing with both in some capacity. If you're interested in distributed tracing and tempo and want to come and see things about that and performance and MCP servers, please go and check out the tempo community call that is in a little less than an hour as well. So yeah, I'm not seeing any questions currently. So yeah, please again, ask questions, join us in Slack. And then we also have forums that you can go to as well. And then there's community.grafana.com. So yeah, I guess thank you everyone, and talk to you all some other time.
Yeah, no, thanks for joining. Definitely reach out with any problem you have. Bye-bye.
And thanks for doing this as well. It's nice having you again.
Yeah, no, always happy to do that. Have a nice rest of your day and enjoy the distributed tracing in a bit.
Thanks. All right, bye.